Back in 2004, you probably remember one of the most powerful earthquakes ever recorded shaking the Indian Ocean. It unleashed that absolutely devastating tsunami. But what you might not know is that long after the water pulled back, the earthquake left behind something else. A quieter, more permanent mark on the landscape. And it created a fascinating scientific puzzle that would take nearly 2 decades to solve.
So this left scientists with a huge question. Beyond the immediate, horrifying destruction of the tsunami, what happens to a coastal ecosystem when the very ground beneath it is suddenly and permanently lifted up or sinks down? We're not talking about a temporary flood here. This was a fundamental reshaping of the world itself.
And this is what that looks like. 2 dramatically different worlds, created by the very same event. In the north, the coast was literally lifted up, becoming drier, more fragmented. But in the south, it sank, creating a permanently flooded landscape. And to figure it all out, scientists basically had this massive, unplanned experiment dropped in their laps.
Yeah, this event, it created a perfect, though tragic, real-world laboratory, a tale of 2 completely transformed coasts. So, just to get our bearings, let's run through the timeline real quick. The earthquake hits in December 2004, causing that permanent shift in the land. But it wasn't until nearly 20 years later, in 2023, that a team of scientists was able to go in and conduct a really detailed study on the long-term consequences.
So let's break down exactly how these 2 opposing forces worked. In the north, the land was physically pushed up by over a meter. Think about that. That caused the sea to actually retreat and the land to dry out. But in the south, the land sank, leading to permanent flooding. One event created a world mimicking a sudden sea level drop, and another a world of permanent sea level rise, all from one single event.
Okay, so to really understand what was going on in these new worlds, scientists needed a witness, someone who'd been there the whole time, working on the front lines. And believe it or not, they found them.
I mean, think about it. With the entire landscape just flipped on its head, where would you even begin to look for clues? The answer, it turns out, wasn't in the big trees, but in the tiny, tireless workers on the mangrove forest floor, the crabs.
You see, mangrove crabs aren't just living there. They're what biologists call ecosystem engineers, and that's a fancy term for something really cool. They're like the construction crew, the sanitation department, and the gardeners all rolled into one. They literally shape the world around them.
And their job description? Oh, it's huge. They're shredding up leaves, recycling nutrients back into the system. Their burrows bring oxygen down into that dense mud so the mangrove roots can breathe. They're constantly moving nutrients around, fueling everything. The bottom line is, their health is a direct mirror of the ecosystem's health. They're the perfect little bioindicators.
So right, if you want to know how the forest is doing, you ask the crabs. But how? How do you actually ask a whole community of crabs about its health and stability?
Well, one of the first things scientists looked at is a concept called functional redundancy. And the best way to get your head around it is with this analogy. Think of an ecosystem like a company. If only one person knows how to do a critical job and they quit, the whole operation could grind to a halt, right? But if lots of people are cross-trained for that job, the company is resilient. It's the exact same idea with crabs. Are there many different species all doing the same important job, or just one?
Next, they measured something called species turnover, which is pretty much what it sounds like. A measure of how much the crab community changes as you move from one spot to the next. If you have high turnover, it's like walking from one town to the next and finding a completely new population. That tells you things are fragmented, maybe unstable. But if it's low turnover, that suggests the ecosystem is connected, stable.
Okay, so armed with these tools, the researchers could finally deliver a verdict on these 2 new worlds. And what they found was a story of fragility and surprising resilience.
And the verdict? It was crystal clear. The uplifted, drier sites, they showed low species diversity and low functional redundancy. If we go back to that company analogy, it's like having just a few specialists. If they go, the whole operation is incredibly vulnerable. The subsided, flooded sites, though, had higher diversity and way more redundancy, making them far more resilient to collapse.
In fact, the researchers put it pretty bluntly in their paper, stating that coastal uplift, which, remember, mimics a sea level drop, is actually more damaging to the crab community than coastal subsidence or sea level rise. And honestly, this was a huge surprise. You can really see that change in this chart here. Just look at the difference in the color bars. The mix of crab families in the uplifted sites up top is completely different from the control and the subsided areas below.
This tells us the ecosystem isn't just weaker, it's become a fundamentally different system altogether.
And you can see this change reflected in the crab's traits too. In these harsh, dry, uplifted zones, it was like an environmental filter. Only crabs with very specific survival skills made it through. The winners here were the smaller crabs and the ones that were really good burrowers, traits that are perfect for conserving water and escaping those tough surface conditions.
But flip over to the flooded zones, and a totally different set of skills was rewarded. The survivors here were the omnivores and the scavengers. I mean, with so many trees drowned and decaying in the water, there was a ton of organic stuff to eat. So the crabs that could eat pretty much anything, they thrived. A completely different survival strategy.
So, okay, this is a really fascinating story about crabs on a remote group of islands. But the reason it's so important, the reason we're talking about it, is because it offers some powerful lessons for our own rapidly changing world.
So why should we care about this beyond these islands? Well, because this natural experiment is a preview of what global sea level change could mean for coasts everywhere. And this is the key takeaway. Losing species isn't just about the numbers ticking down. It's about losing the critical jobs that those species do. When you lose that backup, that redundancy, the whole system becomes fragile.
When you boil it all down, the study reveals this one crucial insight. While losing coastal land to rising seas is obviously damaging, this research suggests that gaining ground, but in the wrong way, can be absolutely catastrophic for the very heart of a coastal ecosystem.
You know, that 2004 earthquake, it gave us a tragic but an absolutely invaluable 2-decade head start in understanding what happens when our world shifts right under our feet. So the final question is really for all of us. As coastlines continue to change everywhere, what lessons will we choose to learn from the crabs?